Your journal doesn't remember you, but mine does. If you wrote in your journal a few months ago about being overwhelmed, but didn't actually use the word overwhelmed, would you be able to find it, reference it, search for it? Probably not, but my journal can. So, what I'm going to talk about today is actually something really cool that I'm building right now. Essentially, what it's known as is using database vectors to create this sort of semantic search that can look up past entries related to what you journaled about today. Um, let's go and take a look underneath the hood to actually show what I'm building. So you can see here on the right, this is my journal from today. I basically noted that I was feeling pretty tired, but I think it's a good tired because I was basically having fun out with my friends yesterday. There was a house party that we went to for my friend Brando and Audrey that they just moved into. And then I went to a bar later and it was great, right? And so what I have here now is basically you can search past memories if you use your little reflect. So if I hit reflect with Pip, Pip is just a name that I'm trying out as I sort of build this out. It can basically go back and search for relevant memories that you've had in the past. So if I click on this one, say revisit a past memory, I'm actually going to see a memory from December 13th of last year, which was, funny enough, me at a house party. And basically how that works is through this semantic search that I'm going to talk through. So how this works, right? Keyword search versus semantic search. We're going to talk about what's the difference and how this works and applies to actually revisiting past memories. So a keyword search basically looks for like an exact match or a like. So if you had overwhelmed, it would look for the exact match of overwhelmed. How semantic search though works is it looks for what did you mean. So if you talked about having anxiety, stress, all those other emotions that are basically adjacent to feeling overwhelmed, that's what semantic search is going to look for. A little thing that I wrote down. My puppy kept me up all night and exhausted from the new rescue, right? That's great. But keyword search might not find that those are actually related or unrelated. How semantic search basically works is it understands it's about the same idea because it's able to link those two together and understand that the puppy keeping you up all night also related to the exhaustion from the new rescue because the new rescue is the puppy, right? You don't compare text character by character, you're comparing it by meaning representation, which is through vectors. So we're going to create a table. And that table is basically going to be what is able to create the embeddings for semantic search as it references things that have happened in the past. So we create this table, we'll just call it entry memories for reference, and where it gets into the vector space is essentially we're going to create this embedding, which is a vector 768. And that's going to refer to basically how many or how large the actual model that we're going to use for these embeddings. 768 is a number, but it's relevant because it then creates a digital sort of like fingerprint to reference the meaning of what you input. It doesn't actually store any text, but it's basically creating an identity to associate with that journal based on the intent of what you created. So if you said something like, I was super happy today, that's going to store it as a coordinate within the vector search and basically have something like, I don't know, 1, for example. 1 is super positive. And so anything that is also adjacently happy in the future is going to be stored awfully close to that 1. Conversely, if it was something very negative, you were sad, upset, that might be the opposite and a lot closer to 0, right? So it's able to basically relate. If it's 1, it's happy, 0, it's not happy. And that's how it's able to reference these past memories because when I was talking about going to a house party, right, that's going to get a vector reference number that's going to say something like this is a house party related. And so when it searches in the past memory, it's going to see that house party. Well, granted, that is sort of the same word, but they're also stored closely together because that also received an embedding at some point that was similar to like a 1 in that example if these were both 1s. And how we're able to basically index that is with this create index, right? So this basically makes it so we don't have to scan every single vector. It makes it so it's actually like an optimized search for when it actually queries all of those to compare each other to. And essentially what we have here is nearest neighbor search, cosine distance. So what that means is basically the distance between what we're trying to return. So when we say find similar entries, query embedding 768, we're using that 768 embedding to basically look up what is the closest thing to the current one that we're searching against. So obviously we have our user ID. We're going to turn a match count of 3. So basically the top 3 previous entries that are related or similar to the one that we basically currently input, house party, for example. So what happens is when we're reflecting on what you just wrote, it basically is going to store that entry as a normal save for your data, for your user, right? And it's going to create an embedding. So you get an embedding per entry, and that basically creates those data points within the vector search that can then be referenced in the future for any new entries, right? To basically look for that sort of similarity, right? So real quick, let's talk about how it finds things that are relevant in close-in search. This 0.72 is basically the number that we're going to set for that cosine similarity to find past entries that are related to each other. If it's not higher than 0.72, it's basically not going to return anything because it's only going to want to look for memories that are actually close to what you're writing about, and it's not going to create anything or hallucinate or return something that's not actually relevant. So that's where we set this cosine number, and you basically set that within the back end of your PG vector database, and it's going to look for anything that's higher than a 0.72. That's how you get that sort of close similarity in terms of previous or past entries when it's returning those memories. The journal reflects on what you just wrote. The flow is 1, save the current entry, store it, and embed it with a new query vector. 2, search against your past embeddings for things that are going to be related, such as your cosine or difference between past entries. Basically looking for things that are similar based on what you just input in this entry. 3, that's that similarity that I was kind of talking about, cosine distance, so the difference between 2 vectors and what you saved. So if you're super happy, the distance between another entry that's super happy is going to be relatively small. And we're going to want to return things like that, right? Basically looking for things that are similar. And then 4, it's going to take that top match, and it's just basically going to return the one with the highest likelihood of being relevant. In this case, right, house parties ended up being pretty close to house parties. I was also tired in both entries. Makes sense. And no, it's not magic. It's basically just using database retrievals to generate a real excerpt from the past and return it based on what you currently input. When is a good time to use it versus not use it? Use vectors when meaning matters. Wording varies. You have unstructured text, data, journals, in this case, right? And you want something to actually be similar to it. You stick with the keyword SQL when exact matches matter. If you need something returning one-to-one, SQL obviously would be good for that because it's structured and it's going to look for an exact comparison. Things like your name or your email address. Things that are important to know is that this does include some API calls, right? Storage, perfvector, index tuning, all the things that come with running any sort of infrastructure for an application. So just keep in mind that it can get expensive if you're just doing tons of vector searches and a lot of embeddings and a lot of things like that. Also, if you're using very intense large models. And privacy. Embeddings aren't human readable, but they're still data. So even though it's going to be some random number that's like 0.1480, blah, 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 right? That's still tied to something, but we obviously keep it super secure, and you wouldn't be able to see what exact one is referenced to which unless you're able to do some advanced querying and stuff like that. So you'll never actually be able to see it, but that's just, again, it's data. So not every search needs AI. So the stack in one line: journal text, embedding model, PG vector similarity search, and then a real past moment that's happened to you. Reference based on what you input into that day. If you're building anything where users write with their words, journals, notes, therapy, things that are important, right? Semantic search is worth understanding if you're going to look at things like using vector search within your databases, Pinecone or Postgres. I'm Jack. I'm building Lost in Thought. This is something that's currently in beta, but I hope it seems interesting. And if you like this sort of thing or want to see me continuing to make stuff like this, check out Lost in Thought and let me know. Leave comments, reach out to me. I hope you enjoyed it. So, yeah.